In this session, we talk about resistors in series. If two resistors R1 and R2 are connected in series, then the same current I flows through both of them. So that is how we identify resistors in series, because the same current flows through all of them. Now, from Ohm's law we know the potential difference between these 2 points is I times R1, and the potential difference between these 2 points is I times R2. So this point is at a higher potential compared to this point by IR1, and this point is at a higher potential compared to this point by IR2. So if we add up these two potential differences, then this point is higher than this point in potential by IR1 plus IR2. So the total potential difference between these 2 points is IR1 plus IR2. Now, if we want to replace these two resistors by one single equivalent resistance, then we draw this diagram again and we replace these two by one R equivalent. So this is the equivalent resistor of these two resistors. So as it is equivalent, everything will be retained. For example, the current will remain the same as it was before, and the potential difference, which was I R1 plus R2, will also remain the same. So now I R1 plus R2 is equal to I times R equivalent. Again we are using Ohm's law. So I times R1 plus R2 is equal to I times R equivalent. So we cancel I from both sides and we get R equivalent is equal to R1 plus R2. So the equivalent resistance of two resistors in series is basically the sum of the two resistors. For example, if we have 10 ohm resistor and 4 such resistors in series, so the equivalent resistance between these 2 points is going to be 10 plus 10 plus 10 plus 10, that is 40 ohm. So we can replace these 4 resistors by one 40 ohm resistor. 40 ohm resistor. So that is how we find the equivalent resistance of resistors in series. Thanks for watching.